Okay, this is the part 3 of the application of Q equals MC theta. In our previous lesson, we learned about how to calculate the final temperature of object of different initial temperature. But our examples only show that the objects are of the same material. What if the objects are made of different material? The method is actually not very different, except that you need to take note of the different material specific capacity. Using this example, an iron block with initial temperature of 80 degrees of mass of 2 kg is cooled by dropping it into cold water with initial temperature of 30 degrees Celsius of mass 1 kg. Calculate the final temperature of both the iron and water given that specific capacity of iron and water is 450 and 4002. Of course, assume that there's no loss on thermal energy to the surroundings. The method is the same. The energy lost by the iron will be gained by the water, so there will be some final temperature of delta F, and each iron will have this MC delta, and water will have their MC delta as stated over here. So this is iron, this is water. So the iron dropped by a temperature delta I, the water it rise by a temperature delta W. Substituting the value, okay, each respective mass of iron is 2, specific capacity of iron is 450, and this is the temperature drop of the iron, and this is for water. Okay, do the mathematical calculation and expand. So you find that this will be this equation, and group the delta F together and add them up, and you should get the temperature of 38.8 degrees Celsius. Okay, so in this case, the iron is actually quite mass is bigger, okay, than the water, but you find that the temperature is actually closer to the water. It's because water have a very high specific capacity which can absorb a lot of energy from the iron. Let's do the opposite. This time round, the iron block is a initial temperature of 30 degrees Celsius, same mass, but it's dropped into hot water of 80 degrees Celsius at mass 1 kg. So notice that I put the water on top and iron below is because conceptually iron is colder, so it rises temperature, and water is hotter, it drops in temperature. So that's how I view it. So the method is still the same, except that this time around the water is the one that is losing energy, iron is the one that is gaining energy. So have to be careful. Okay, this is water and this is iron. So the same thing, the temperature drop and the temperature rise of iron. Substitute in the value. Okay, do the expansion accordingly. And group your delta F together. And this time round, your final temperature is 71.1 degrees Celsius, which is closer to hot water. What if there are more than 2 objects? So taking this example, if I have this iron and the water in an aluminium tank. So there's actually 3 materials: iron, water, and aluminium tank. Again, the overall concept is actually the same. Energy lost by the hotter objects is gained by the colder objects. So for this particular case, the energy lost is iron. The energy gain is the water and the aluminium. So the key is actually to identify which object is gaining or losing thermal energy. So using this as an example, okay, some crucial information: initial temperature, mass of iron, water, initial temperature, mass, and the aluminium tank of 0.7. Okay, for this aluminium tank, what is the temperature of the aluminium is assumed to be 30 degrees Celsius, same as the water. So given specific capacity of iron, water, and aluminium, okay, these are the values. Energy loss is equal to energy gain. In this case, the loss by iron is gained by the aluminium and gained by the water. Okay, I sort of like color coded it so that it's easier for you to see. Okay, then this is the final temperature. So again, each have their own MC delta. So the loss in temperature by the iron and the gain of temperature of the aluminium and the water, which is actually the same. So put in the respective value: 2450 temperature drop, mass of aluminium, specific capacity of aluminium, and the temperature rise, and this for water. So solve accordingly. Okay, and of course this time round you have two parts, you just add them together and you get this 4830. And then expand, same thing, group the delta F together, the numerals on the other side, and you get this 50.4 degrees Celsius. Okay, before we go, this is a practice question for you. It's the exact same scenario, but this time round, during the cooling process, there's also a loss of thermal energy of 100,000 joules from the iron block to the surroundings. So how do you calculate the final temperature of this setup? Okay, the hint is that the loss of thermal energy is also mean a gain in thermal energy for the surroundings. So how do you incorporate that? The answer is 33.0 degrees. Okay, this ends of today's lesson. Thank you. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.